Ever taken antibiotics? Did you follow the directions completely? All antibiotics need to be taken as directed, which usually means taking all the pills and not stopping, even if you begin to feel better. This lab will answer why. Materials that are required for the Antibiotic Resistance Lab are some objects, and I have about 20 of each. I have about 20 blue discs in this case, about the same amount of yellow discs and red discs. The blue discs represent least resistant bacteria, meaning that they will die the quickest when exposed to antibiotics. Then I have resistant bacteria and I have extremely resistant bacteria. If you don't have chips, you can use things like paper clips, nails, screws, coins, or even different colored pieces of paper. You're going to want to lay them out so there are 13 of the least resistant. So you have 13 of the least resistant, 6 of the resistant, and 1 representing the extremely resistant bacteria. You're also going to need a dye. And you can take this from like one of your existing games that you have at home. And if you don't have a dye, you can also maybe use an app on your phone. The dye is very important, and there's a specific code. If you have a 1, 3, 5, or 6, it means you took your antibiotic and you remove 5 chips. If you roll a 2 or a 4, it means you forgot your antibiotic. Those numbers are very important. Also, after every turn, you're going to add 1 chip to the existing bacteria population. I'm going to go through this with you. So I rolled a 3, which means I took my antibiotic. So I removed 5. You're going to work across the board. So I'm going to remove 5 from this population here. However, every turn I add 1 to every existing population. So since there's blue ones here, I'm going to add another blue one. There's yellow, I'm going to add yellow, and there's red, I'm going to add red. I roll my dice, and I rolled a 5. I took my antibiotic again. I'm going to take 5, 1, 2, 3, 4, 5, and I'm going to add 1 to each population. After each turn, I'm recording my data in my data table. In this case, I got a 1, so I'm going to remove all 5 in this case. However, since there's no more of these, I can no longer add 1 to this population because they're not breeding. But I'm going to add 1 from here, 1 to here. I got a 2, so I forgot to take my antibiotic, so I'm not going to remove any. However, I still am going to add to my population. Again, after every turn, I'm recording my numbers. 3, I took my antibiotic, 1, 2, 3, 5, and again, I go through. Another 3, 1, 2, 3, 4, 5. Add another one. Oh, forgot to take my antibiotic. They're going to reproduce. I got a 5. I'm going to take 1, 2, 3 from here and 2 from here, which makes my 5. Now you're going to do this until you reach your 8 days of your antibiotic. After 8 days, if you're able to wipe out all of the population of bacteria, you live. However, if you still have some left over, you will then die. Remember to complete your data table. We started with 13, 6, and 1. We rolled our dice. We then take away or add however many, and then you're going to add them in again. And you're going to go and complete this. This represents the total days that you take your antibiotic. Ideally, you want to end up with 0. The purpose of this lab is to show you that over time, you have more of the extremely resistant bacteria available. And this is why it is very, very important to complete your entire course of antibiotics, complete your entire prescription, because otherwise you get these extremely resistant bacteria in the population.